Hi everyone. You might have seen the various types of the equations in the mathematics. Some types of the equations include only two constants and some equations only include three constants. As well, there are lots of equations which can include four constants. But the reason that I'm going to make this video for this kind of an equation known as the most beautiful equation in mathematics lies in the fact that it includes five constants in it. So the fact that makes this equation the most beautiful equation in mathematics is only because the equation consists of five constants in it, and these constants are not the local constants. They include all the branches of the mathematics. From different branches of the mathematics we have put these constants and fit them in this equation. So these constants are actually from algebra, and some are from trigonometry, and some are from our natural number system, and some are from the whole number system as well. And these constants are grouped together, and we have put them in this equation so that the equation becomes the most beautiful equation in mathematics. Now you know that in mathematics it is not allowed that we can take the square root of any kind of a negative number. So you cannot write like this. You can find root of -2 or root of -1 or root of -3. We can't find them. And that is the reason that in the mathematics there comes the different branch known as the complex analysis, which actually allows us to do so. And it was also the Euler in the late 18th century that he discovered the different branch of the mathematics. He was a genius mathematician, as you all know. So first of all, let us try to understand about what actually under root of -1 is. So firstly we will see what under root of -1 is, then we will look at the most beautiful equation in mathematics. Okay, so let me clear this. So you know that if I'm going to give you any number like 4, and I will tell you to find out the square root of 4, and you can easily find. For example, you can write under root of 4 to be equal to 2, and you can write root of 16 to be equal to 4, and similarly you can write root of 49 to be equal to 7. So easily you can find it. And even it is not, it's not for only the perfect squares. You can also find for any number. For example, you can find for root of 1 to be 1, and root of 2 to be something, root of 3 to be something, and you can find it for every kind of a natural number, including point numbers, decimal numbers, fraction numbers. You can find it. But then there comes a problem when you have to find this thing, that is the square root, for the negative numbers, for the negative natural numbers, for the negative decimal numbers as well. For example, if I will tell you to find out under root of -1, so you are not having any choice. So until it comes to the fact that under root of -1 is actually equal to iota. So यहाँ पर जो ऑयलर की फॉर्मेशन थी, जो ऑयलर ने हमें दे दिया, उन्होंने एक नोटेशन बना दी, बताया कि जो अंडर रूट ऑफ -1 है इसको हम iota से डिनोट करेंगे. Now he denoted this under root of -1 to be equal to iota, and you can easily now find the value of different things. For example, you need to find out minus times of 2. So you can now write it as equal to under root of -1 into 2. So you know that this root -1 is iota, and you can write root 2 times of iota. So the things gets clear now. Okay, so now this iota is very special in case of this, the most beautiful equation in mathematics, because we know that iota is now equal to under root of -1. Okay, so if I will now include this iota in the equation, so there will be no problem for even the students which are from non-math background. Okay, so now I'm going to use this constant in this equation, and you will see that what this equation is actually. So till I have only one constant, I have gathered only one constant, that is iota, and the value of iota is equal to under root of -1. Okay, so another kind of constant you know that in mathematics, which is pi. So you know that pi is a constant, and it is having its value to be equal to 3.141, and you can write it as 59 and so on. And remember that it is an irrational number, so you cannot say that it is having any kind of a particular behavior, it is having any kind of a sequential type of behavior after the decimal point, because it is an irrational number. Okay, and also there is another one more important constant, that is actually e. So that is a very special kind of a constant, and let me denote this e to be equal to, and actually not denote, it is having its value to be equal to, say it is 2.71828, and it is going on. Okay, so this is one constant, this is another constant, and this is the third constant. So this is iota, this is pi, and this is e. Now you know that 1 is a constant, so let me gather this 1 here, and also you know 0 is a constant, so let me collect this 0 here. So these are total now 5 constants. Okay, these are total now 5 constants. So these are the constants. Okay, these are the constants. Now what this Euler said in its most beautiful equation, what he actually formed is that if I write here e and I will give it a power to iota times of pi, that is iota pi, and I will add it 1 and it is equal to 0. And it is not that I am mixing up these kinds of the constants on my own. So it is a full proved result that e power of iota pi, if you add it 1, it gives you answer to be equal to 0. And see that what's the beauty of the mathematics in it. You know that e is actually having value to be 2.71828 and it is running up to infinity. And iota is having its value to be equal to under root of -1. And this pi is having its value 3 point something. And plus 1 is a positive quantity. So you are adding them. And even if you will tell it to some other non-math student that what will be its value, he will not go to 0. So it will not have its idea that it will return the value to be equal to 0. It will say that it might return -1 or 3 or 4 or any number, but not 0. But see the beauty of the mathematics lies here that e power of iota pi is coming to be out equal to 0, and I will make it in a box. So the equation is a very beautiful equation. It includes 5 constants in it, and you can also write this equation as e power iota pi to be equal to minus times of 1. You can also write it like this. So see the beauty of maths here, and that this is the reason that this equation is the most beautiful equation in mathematics, because it involves 5 constants in it. And the second fact is that if we will only calculate e power of iota pi plus times of 1, and we'll tell to some other non-math student, and he will definitely say that even a math student, he cannot imagine that its value can be equal to 0, but it is having its value to be equal to 0 despite of having such kind of the constant values, and it's having its value to be equal to 0, and this makes it the most beautiful equation in mathematics. So whenever you want to find out the most beautiful equation in the mathematics, that is only the Euler's equation, and you can write it as, the equation is also called as Euler's EULERS equation. So the equation is also called as Euler's equation and is the most beautiful equation in mathematics. Thank you so much.